Hi everyone, we are Unstartable DEs, and today we'll talk about our final demos. So let's welcome Lins to talk about the backgrounds.
Hello, good afternoon, everyone. Today, my name is Lin. Today, I would like to talk about the background of our project. First, I will define the business problems, then explain the purpose of our project, and finally, we'll describe what benefit to solve these problems. In today's information-rich and diverse marketplace, providing accurate and personalized product recommendation to the user is a challenge. Traditional methods, such as relying on the salesperson's intuitions and personal knowledge, are no longer enough to meet the evolving need and expectation of the customers. Next slide. The project aims to address this challenge of providing accurate and personalized product recommendation by building a ETL architecture for data processing, advanced technical, including machine learning accuracy, and data analysis tool will be utilized to solve items and based on similar items for the user's research. The project also focuses on providing a personalized recommendation to users during their shopping experience, improving the overall user experience and driving business growth. Next slide. The benefit of solving these problems. First is improve the user experience. Second is increase the revenue of product. Third, enhance product development and marketing strategy. Fourth, improve the customer engagement and loyalty. Finally, enable more cost-effective and add more selling. Target message and promotion for the personalized recommendation require less marketing effort, making it a more cost-effective approach. Next, welcome my team member Kevin to talk about the architecture design.
Thank you. So data infrastructure encompasses the foundation system and technologies that enable the data storage, processing, and management of data, forming the backbones of data pipelines, data storage, data processing, and data analytics within a system. So in our project, the data infrastructure consists of the following key components. Firstly, data storage is essential to handle a vast amount of data. To simulate a production environment, we utilize AWS RDS as a relational database to store and manage our raw data. Once the raw data has been cleaned, it is stored in an AWS S3 bucket, which serves as an object storage system. Secondly, data processing is crucial for transforming and delivering value from the data. We use AWS Glue to perform the extract, transform, load process and construct a data catalog. Through a Glue ETL job, we transform the clean data stored in S3 into a format that provides meaningful insights, and the resulting data is also stored in S3. For data orchestration, we utilize AWS DMS to synchronize and replicate required data from the source database to AWS S3. Additionally, we also use AWS Lambda function to automate the entire recommendation process. The next component is the recommendation engine, which plays a vital role in our data infrastructure. By applying algorithms applying algorithms to the processed data, we generate personalized recommendations for users. To establish seamless communication with users, we incorporated a data connectivity gateway. APIs serve as the conduit for data flow between our internal data system and the outside world. We used AWS API Gateway to enable interaction with end users, facilitating the exchange of data. Data backup plans are also a crucial aspect of our data infrastructure. They act as a safety net, ensuring data availability and recoverability in the event of a disaster. Our approach involves running a full backup initially with the data available. Subsequently, we also perform incremental backups on a daily basis to keep our backup up to date. Next, I would like to introduce Ashley to talk about data source.
Thanks, Kevin. So here is the part of data source creation and ingestion. So in this project, we have 6 CSV local files, and to simulate the real industrial environment, production environment, we decided to use the relational data service from Amazon, and then you create a DB retail as our source system. And then we use the load data local in file to load the local files into the RDS created to simulate a source system. And then we use the data migration service. We followed the following steps. We created the replication instance, the retail raw data replication, and then we configured source and target endpoints. So the source is the RDS we created, and the target endpoints has 2 separate endpoints landed in a S3 bucket. So one of them is the change CDC functionality. The other one is the full load. As we can see from the right bottom, there is a screenshot that shows the two folders with different data loading strategies. And then the next step is we created data migration tasks. So when it comes to the raw data bucket, we have full load and then CDC folders. When we configure the CDC endpoint, we enable the data partition functionality based on date information. So in this way, we can increase the scalability and optimize the performance. After all of these steps, the next one is to go through the transformation process, and over to Tom to give us more information about how the ETL jobs works and how the data table is populated.
Thanks, Ashley. As graphic shows, the ELT procedure begins with the extraction of the CSV files from the S3 bucket named retail raw data bucket. The first group job, called orders for daily ELT job, carry out a basic table transformation for pre-data processing activities, such as data validation, cleaning, and standardization. The data catalog table for orders load table and the CSV file in the 3 buckets retail clean data bucket will produce the output. Following this, the second group job for orders with the rank daily ELT job retrieve the clean CSV file from the previous S3 bucket and execute a more complicated data transformation process. Consequently, the final data is transferred and stored in the S3 bucket, retail transfer data bucket. An external table called user preference is also created, which can be queried by using AWS Athena for the following process. The entire data ELT process is completely managed by a AWS group workflow called the daily recommendation pipeline, operating daily without a human intervention. Furthermore, data partition is implemented based on the collection date, and replication and life cycle rules are put in place for disaster recovery and resource and cost management. S3 buckets, particularly the final transfer bucket, are automatically backed up daily, and data is transferred into another S3 bucket, while incomplete and out-of-date data files will be removed from the original S3 bucket. In the next, please. Well, in the initial ELT group job, the orders tables and the order product profile table are loaded from the S3 bucket. And the column names are standardized. Two tables are then joined using an order ID column, and duplicate column order ID is subsequently dropped. The result is a filter to select only the prior data and the pre-processing steps such as removing duplicated rows, null values in specific rows, and adding collection date for data partition are performed. The result is a clean table stored in the S3 bucket, retail clean data bucket, and a catalog table for orders load table is created. Next, please. In the second ELT group job, the with rank table from the first job is loaded from the S3 bucket, retail clean data bucket, along with the products table from the S3 bucket, retail low data bucket. The data type changes and the transformation are made to the with rank table, and the column names are adjusted in the product table. These tables are then joined using the product ID column. The final step is to repartition the CSV file into only one file and store in the S3 bucket retail transform data bucket. A catalog table user preference is also created, accessible for the querying by Athena for subsequent API output. In summary, two ELT group jobs are used for data manipulation and transformation process, while catalog tables are generated to provide a centralized and systematic method for data management and analysis. The final transformed CSV files are secure stored in the S3 buckets with consideration made for data partition, high availability, disaster recovery, and cost effectiveness consideration. Next, we'll please welcome the Lynn to explain the next session. Thank you.
Thank you, Tom. This is our API gateway flow. User make a request through the web app interface. Request is sent through the API gateway. API gateway forward request to the Lambda function. A Lambda function initiate a query through the Athena. Athena execute the query and restrict the query result. Query result is sent back to the Lambda function. Lambda function prepare the response. Response is sent through the API gateway. API gateway forward to the response to the web interface. The web interface will display the response to the user. Next slide. Below is the Lambda function and API gateway we built for this project. Next slide. This is our result. Yeah. Next slide. We use the GitHub to store and manage the code and field associated with our data pipeline. This enables convenient version control and promote quality development among the team members. Next, welcome our team member Ren to talk about the future work.
About the future work, we still have lots of things we can do. As our previous slide showed, our current project just complete the API function. So in the future, we will better present the API function on the website rather than using Postman to show the outcomes. And we have to add the machine learning part in our project too. So furthermore, business analysis is also an important part. To increase the user experience and more accurate recommendations, firstly, we can try different kinds of machine learning algorithms in our systems. And we also can collect user feedback in different kinds of ways, like tracking users' browse history or what kind of product they click, but they didn't buy it. And the next, build a real-time recommendation systems. It make user have a better user experience too. And next work is A/B testing platforms. We can have a platform to test different machine learning algorithms or different recommendation strategies. And B platforms have the original systems, so we can compare which kinds of strategies will have a better satisfaction for users. So about the structures part, we can have data architectures to monitor different services in our systems so that we can know what happened when there are some errors. The final thing is we can have more communication with DevOps to complete our systems. So thank you, everyone. It's the end of our presentation.